Hey everyone, welcome back to my channel. So today we're going to be looking at 9.1.1 of 2012 Building Code Compendium. So let's turn to the OBC of part 9, where we're going to look on page 5. It says part 9.1.1.7 Radon. What is a radon? So if you read that itself, it says a radon is a radioactive gas found naturally in the environment. It has no color, no odor, and no taste. It is released into the air during natural breakdown of uranium in rocks and soil. Uranium are used for chemical weapons and etc. Once released, radon breaks down into radioactive elements that can attach to dust and other substances in the air we breathe. So let's look at this little image on the right side of my screen. Do you see these little red lines? And then it go into the building itself. So imagine this gas is is spreading from the the earth itself. The building exposed to these gases. So because buildings are not really sealed tight when constructed in Canada from certain gases, gas will go through the walls, maybe windows, and the list goes on, even the shower itself. Now, building constructed in the city listed in the following section. So if you refer to the building code, there's a list of city there. That's A, B, and C. Must be designed and constructed to prevent an annual average concentration of radon 222 and does not exceed 200 becquerel. Just know I can't pronounce the word. Becquerel per cubic meter, or 0.2 working levels inside the building. So I would just advise you to go into the OBC and read through that same section and try to understand it. And this is just a guide here, or a breakdown of what you're looking at of that particular section. And you can compare both of them. Now 9.1.1.8, building in floodplain. So what can we consider a floodplain? So imagine you have a stream, a lake, or something like that, and houses are constructed next to that area. We can consider that as a floodplain, or a building on a swamp is a floodplain. So a building on a floodplain shall be designed and constructed according to good engineering practices. Refer to Division C. So this is just a take for you. Please review this section, Part 1 at 1.2.1.2 for more information. More information on good engineer practices. So there are a few things that when you're designing, when you should practice good engineering or architectural practices, well then you can find those there. Now, prevent vertical and horizontal damages to the structure if hydrostatic pressure arises. So imagine the same building over here on my right side of the screen. You see it has a floodplain here. So imagine water increases and then it's going to pass the foundation. So water is going to go at the bottom of this floor. So what we don't want to do is to have the water pressure damage the foundation wall or the floor. Yes, it can penetrate through the building, that's fine, but we don't want it damaging the structure of the building itself. Now, imagine water entering into the building. We just don't want water to affect the egress or mean of egress during an actual flood. So we must keep that safe, that particular area safe. Now we're gonna move into site assembly and factory as built building. And we all know this as building that is built in a factory or site assembly is basically built on site. Now CSA Z240.2 refer to manufacture intended for residential occupancy constructed not wider than 4.88 meter. Now CSA A277 produce the factory certification of building. Just keep this in mind. You don't really need to know it, but I just put it in there so that you will kind of understand or get aware of what the OBC looks like sometimes. So what's a house? A house is permitted to be above another house provided there is no more than one dwelling unit in each house. So you can definitely have a 2-story or 3-story house, but there must only be one dwelling unit in each house itself. Now we're gonna move down to materials 3.9. So this will most likely be concrete. Reinforcement and unreinforcement concrete are constructed as our class. Structural reinforcement concrete shall be designed according to part 4. And again, structural reinforcement concrete. There's some reinforcement concrete that can be designed according to part 9. Now, what are we looking at for concrete? Compression strength, 28 days. This is the maximum time period which a concrete gets to gain its full strength. So 32 MPa garage floor, 20 MPa interior floor, 15 MPa all other application, and I put 2 here: storage, shed, based, or drains. I hope this is transparent to you. Now let's move to the concrete mixture water rate. So these guys are mixing concrete. It definitely needs water. So if you're gonna mix concrete for a garage floor, then you need 0.45 percentage of water, 0.65, 0.7. Now, why do you see that there's a little bit less water for this 32 MP and then the water keep increasing? It's because concrete needs a bit of water to form, but the less water it has, and it does keep itself together, is more strength it gets. So if you see a 32 MPa, for it to have that strength, then you need to add less water. Water tends to take away the strength from concrete. Now we're gonna look at this table here in 9.3.1.7. Now we're going to look at maximum size of coarse aggregate, millimeters. So what is coarse aggregate? It's just the stones. And this, you can see aggregates. I put a little example here for you. Now we're going to look at this little diagram. You see cement, sand, and gravel. And then that's equal to concrete, or the mixture itself, mortar, whatever we want to call that. And at the bottom of this table, it says a 40-gram bag of cement contains 28 liter. Now 1 kg is equal to 0.7 liter. Just keep this in mind, but focused on this number. 48-gram bag of cement contains 28 liter. Now 14 millimeter aggregate, we need parts or bags, 1 bag of cement. Then we need 1.75 bag of aggregate, and we would need 2 bags of coarse aggregate. Now 20 millimeter of aggregate is equal to 28 liter, which is still 1 bag of cement, 49 liter, which is 1.75 bags of fine aggregate, and 70 liter coarse aggregate, which is 1.5 bag of the coarse aggregate. So I hope you understand this table. And we will lastly move on to 9.3.1.9, cold weather requirements. If temperature are below 5 degrees Celsius, so imagine it's winter outside, we're looking at anything at 0 degrees or so forth. Concrete shall be kept at no less than 10 degrees Celsius. So if we are deciding to pour concrete on a snowy day, then the space where we are pouring the concrete shall be kept at 10 degrees Celsius. In the summer, again, it shall be kept no more than 5 degrees Celsius. Now, after pouring concrete, whether it's winter, most of the time, if we pour concrete in the winter or in the fall or spring, concrete must be kept, or mortar must be kept at 10 degrees Celsius for 72 hours after being placed. So when we finish placing this concrete here, it must be kept at 10 degrees Celsius for 72 hours. Now, thank you for watching. Please like, share, and subscribe for more video. Bye.